Prove that root 5, root 11 are irrational numbers. In the previous video, we saw how to prove root 2 and root 3. The same way we are going to do root 5 now. So we are assuming root 5 as a rational number. So by assuming root 5 as a rational number, we can write root 5 is equal to P by Q, and by dividing P and Q with their HCF, we can find two co-prime numbers such that root 5 is equal to A by B, and that will mean root 5B is equal to A. Now squaring on both sides gives us root 5 square will be 5 and B square is equal to A square, and from this equation, let's call this one equation 1. We can conclude that 5 is a factor of A square. So according to fundamental theorem of arithmetic, five is also a factor of A. So since 5 is a factor of A, we can write A is equal to 5 into some number, since 5 is a factor of A, and this gives us A square is equal to 25C. Now substituting the value of A square in the first equation, substituting A square in equation 1 gives us, equation 1 was 5B square is equal to A square, so 5B square is equal to, instead of A square we will write 25C square. That will give us, after dividing by 5 on both sides, B square is equal to 5C square, which means 5 is a factor of B square, and again according to fundamental theorem of arithmetic, 5 is also a factor of B. Now we assumed A and B are co-prime. A and B are supposed to be co-prime numbers, but both A and B has 5 as a common factor. This contradiction occurs because of a wrong assumption. Hence, root 5 is an irrational number. Now using the same method, we will try to prove root 11 as a irrational number. So for root 11, assuming root 11 as rational number, so we can write root 11 as p divided by q, where p and q belongs to integers and q is not equal to 0. Now we have got that. We can find co-prime numbers a and b such that root 11 is equal to a by b. We just need to divide p and q with their HCF to get a and b. Now this can be rewritten as b root 11 is equal to a. So now squaring both sides, we will get b square, root 11 square will become 11. So 11b square is equal to a square. And let us consider this as equation 1. Now we can conclude that 11 is a factor of a square. So according to fundamental theorem of arithmetic, 11 is also a factor of a. Since 11 is a factor of a, we can write a is equal to 11 into some constant number, which is c. This is equation 2. Substituting the value of a in first equation, we will get 11b square is equal to 11c square, which gives us 11b square is equal to 121c square. Now dividing by 11 on both sides, we will get b square is equal to 11c square. So again 11 is a factor of b square. So according to fundamental theorem of arithmetic, 11 is also factor of b. Now a and b are co-prime numbers, but both a and b has 11 as a factor. This contradiction occurs because of a wrong assumption. Hence, root 11 is an irrational number. If you have any doubts in this question, feel free to discuss in the comment section. Thank you.